Welcome to our series, Physics Made Easy for 10th Graders. Dig deep into the concept. In this video, the third of the series, we will discuss refraction through a prism. The basics can be found in the blog using the link in the description box. We'll talk about the angle of minimum deviation through a prism, its measurement, and how it can be used to determine the refractive index of the material of the prism. Determination of the angle of minimum deviation of a prism is an important experiment. This is because it yields a precise estimate of the refractive index of the material of the prism. This method is so reliable that the material for which the refractive index has to be determined is cast into a prism, and the angle of minimum deviation is measured. As shown in Figure 1, the angle of deviation is the angle made by the refracted ray Td with the original direction of the incident ray Su. Figure 2 shows the variation of the angle of deviation with the angle of incidence. As the angle of incidence increases along the x-axis, the angle of deviation along the y-axis first decreases to a minimum value and increases afterward. The experiment aims to determine the minimum value of the angle of deviation delta m. We use a prism spectrometer to determine the angle of minimum deviation of a prism. This instrument consists of a prism table, collimator, and telescope, all movable along a vertical axis that passes through the center of the prism table. We mount the prism at the center of the table and direct a parallel beam of light from the collimator at one of the prism faces. The light beam passes through the prism and exits from the opposite face. We have shown here only the axial ray. It is then brought into focus on the image plane of the telescope by the telescope lens. We can change the angle of incidence by rotating the prism while keeping the collimator and source assembly fixed. As the prism table is turned, the angle of incidence changes, and the image of the slit in the eyepiece moves in one direction up to a certain point and then in the opposite direction. The aim is to determine the point of reversal, which is the point of minimum deviation. Bring back the prism to the position of slit reversal. Lock the prism table. We must align the telescope axis with the slit to measure this position. To do this, we turn the telescope, keeping the prism table fixed. By turning the telescope, the field of view with the cross wires scans the emergent face of the prism. We adjust the telescope's position so that the vertical cross wire coincides with the image of the slit. At this position of the telescope, it points along the direction of minimum deviation. We note this position as T-min on the vernier scale. To find the direction of the incident ray, we remove the prism and turn the telescope so that the direct image of the slit falls at the center of the cross wires. We note the telescope position, T0, on the vernier scale. Finally, we calculate the angle of minimum deviation by subtracting T0 from T-min. The refractive index can be calculated using the equation μ equal to sin I by sin R, which is equal to sin A plus delta m by 2 divided by sin A by 2, where A is the refracting angle of the prism, and delta m is the angle of minimum deviation determined using the prism spectrometer as follows. For the proof of this equation, please look at the link in the comment box. The prism is mounted on the prism table. The prism table is adjusted as in the figure. A parallel beam of light from the collimator symmetrically falls on the two lateral faces, AC and AB. The telescope is turned towards the left beam, and the position of the image of the slit is adjusted to coincide with the vertical cross wire. We note the position of the telescope TL on the vernier scale. Similarly, the position of the telescope TR is noted after adjusting the position of the slit of the right beam on the center of the cross wire. The angle m is given by TR minus TL. It can be shown with simple geometry that A equals m by 2. With our measurements of the angle of minimum deviation delta m and the angle of prism A, the refractive index can be calculated using the following equation. A more detailed version can be found in the blog through the link provided in the description box. If you liked the video, Please consider subscribing.